Lesson 4, Chapter 2, Display Data Numerically. This section is very easy and you will enjoy that section. Okay, so it's mainly talking about calculating central tendency. How can I measure tendency or central tendency? You measure it by 3 ways or more: mean, which is average, median, and mode. Okay, and we already learned how to get all of them, right, from previous classes. And we define and identify outliers, and we already did this last class. You remember? Calculate the mean with frequency. This is something new, so we're going to learn this today. Define variability, depressions, which is what? Range, variance, standard deviation. Define and calculate variance. Calculate the range. You already know this, right? How to calculate the range. And interquartile range. You already know how to do this from last class, right? So just repetition. Calculate the standard deviation. This is new for either population or samples. We have also standard deviation with frequencies. Find out how many standard deviation the median is far from the mean. That's the meaning of standard deviation. Okay? And remember, the mean for the sample is going to be X bar. This is called what? X bar. Identify an outlier visually or by formula or by standard deviation in a set of numeric data. Okay? You're going to spend a little bit of time to get the meaning of those words, okay? And write it down. So make sure that you print this or use the PDF and do it on your iPad. So in our previous section, we took a look at how we could summarize data visually, graphs. But quite often, it's going to be useful to summarize data with numbers. So that is going to be our question. How do we summarize data numerically? Here we're going to use different type of measurement: mean, median, and mode. And there is 2 things that we will try and summarize numerically. The first one was going to plan on for the measures of the central tendency, sometimes called measurement of location. Sometimes called central location, and sometimes you call it center, is a way to describe what's typically for a set of data. Where is the middle of the data? That's the question. Where is the middle of the data? And that depends on our context. The measures of center will either be the mean or the median or the mode. Okay. There is a link here for a video. Nice video, you can watch that, okay, after class or at home. So the first question comes here for vocabulary. What is data? Data is what? The smallest unit of factual, which is factual information that can be used as a basis for calculation, reasoning, or discussion. Data is a collection of facts such as numbers, words, measurement, observation, or just description of things. Okay, why do we summarize data? The big discoveries of statistics is data, that we can better understand the world by summarizing the data set. One reason that we summarize data is that it is provides us with a way to generalize. This word is very important. Generalize means take from small groups to large groups or to the population, to make general statements that extend beyond specific observation. How can we calculate the mean? The sum of the data divided by the number of data. Median, how can I get the median? Is the middle number in sets where arranged in order from least to greatest. So the first thing you should do is you have to put the numbers in order first. Mode is the number that occur the most often in your data set. Now, the new part here is variability or dispersion. Dispersion, also called variability, scatter, or spread. Common example for measurements of statistic dispersions are the variance, standard deviation, and interquartile range. Interquartile range, we learned this in the last class, you remember? So what's new today is variance and standard deviation. The range we said from subtract, take away from low to high, and subtract high, yani say highest minus lowest, the lowest number. What is variance? Measurement of the spread between numbers in the data sets. So you have numbers of data and it's spread around on the graph. You can measure the spread, how the spread of data. I think I gave you something like this, maybe one pictures. More specifically, variance measures how far each number in the set is from the mean, or thus from every other numbers in the set. Variance is often depicted by this symbol, which is, this is a symbol for it. Okay. Standard deviation is a number used to measure how spread our data from the set of numbers are from the mean. So there is a little bit difference between standard deviation and variance, but both of them is the same thing, is measuring the spread of data. Okay. The z-value is a measure of the number of standard deviation. The mean is from the median. So you have to memorize this, which is the measures the number of standard deviation. The mean is from the median. You have to memorize this because the rest of the course will be about those three things, three parts here, or the three vocabulary. Okay. Now let's take a look at the symbols. Of course, most of the time we're working on what? Samples. So if you have a case, the number of cases is going to use what? N. Mean, what are you going to use? X bar. Median, what are you going to use? Just abbreviation MED or MD. Standard deviation, what are you going to use? S small. Okay. And the sum of the multiple terms is sigma. Okay. Is this clear? Please differentiate between sigma, standard deviation for population, and the sigma for the sum. Just don't get confused between this and this. Okay. Most of the time we use sample. So we're going to use most often those symbols, okay, or letters. Okay. All right. Here we have summarized data by frequency distribution table. So we're going to take a look at an example here. It said a school conducted a blood donation camp. The blood group of 30 students were recorded as follows. So these are the type of blood. We have A and B and AB and O. Okay. So how many students? Type A, 9. How many students type B? How many times AB? How many O? 12. Okay. You can read those things here. Let's go for another table. Here, obesity, we have two groups, group A and group B. But here we are measuring what? The total number of the sample here is 100. So we're measuring the length for group A.
Doctor, sample?
Yeah, that's sample.
Why is the N capital?
So then it's a population. Okay. So, but I'll assume here is it's a sample. Why? Because the number here is so small.
Yeah.
Okay. So don't worry about. Sometimes I make mistakes, and instead of writing it in small, I just make it in capital. Okay. So here I have two groups, group A and group B, and did the length for them. So I did for the sample here is 100, and the mean was 169. and the standard deviation 5.9. Okay, and group B is the same thing. We did the same thing. We get the mean and the standard deviation. The weight is the same thing, and the body mass, we did this also as well. So you get the numbers for the mean and the standard deviation. We'll learn this later, just like this is like a summary now. Okay, so go through this and go through this by reading it. It's most of the things here we already learned. Now, how can I get the mean? Remember, we're going to use X bar. So how can I get the mean is the sum of X, all the values, divided by the number of the sample, or the sample size, they call it. Okay. So for example, here I have those numbers. I add them and divide by how many they are. So the answer here is 3.625. Is that clear? I think the average is very easy. To get the average or the mean is very easy. Here is this sample for you. Can you do this now? Yalla, do it now, quickly. 2 minutes. You have how many numbers? 5 numbers. So how can you get the sample mean? So you add all of them and divide by 5 and write the answer here. Yalla, do it now. If you have your iPad, do it now. 12. So write down 12.
So we add all of them and then divide it by 5, right?
Right. Okay, question number 2. We have a statistic test and the score were 15, 66, and so on until 95. The mean here, we need to find the mean. Can you find the mean for those data? How many numbers do you have? How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have to divide by 12. Now the question comes here. Did you get the answer? How much?
78.
78. So the average or the mean here is 78. Okay.
Yeah, I got 70.6.
70.6.
15 plus 60.
So is this, the question comes here, is this represent the center of the data, the number you got? Is a good representation of the data? The center? The center means the middle, right? Why not?
Because 17 towards the beginning, right? Because of the outlier.
Because we have an outlier. What is the outlier here? 15. That takes off your average or your mean. So please write this down. If not, because we have an outlier, very small number, that takes off your
So we don't add
your result.
So we don't add the 15 in it?
No, I didn't say you don't add it. I mean, you include it, but it doesn't represent the center of the data. That's the whole, if that's the correct answer. It does not represent the center of the data. Why? Because you have an outlier which is 15. That takes off the data of the accuracy. Okay, now let's take a look at the table. Question number 3. During the first 4 summer Olympic Games attended by the United States, these medal counts were awarded. So, United States during Athens in 1896, how many medals they made? 20. In Paris, 47. St. Louis, 239, and London, 47 medals. Okay, can you calculate the mean? and then circle one of the answers. Finish? What's the answer?
88.
Okay, so circle the correct answer.
Well, it's 88.25, so we're rounding down, right?
Right, it said round it to the nearest whole number.
Oh.
Now, next question, it said calculate the mode. Which number is the most repeated number? 47 is repeated? Then collect 47. If there is no repeated number, then you say what? No mode. Okay? Now we need the median. What is median? The middle number. So you have to put this in order. Right? Is it in order?
It's gonna be 47.
Okay, then you circle the correct answer. Is this clear?
Why did you say that it's 47?
Or that we add 47.
Yeah, but if you divide by 2.
Yeah, it's gonna be, yeah,
47.
47.
Oh, so you can take everything.
Is this clear? All right, let's move to the next one. How do you X bar and mu different in statistics?
X bar is used in the sample with the mu is used in the population.
Right, write the answer here. So if you want to answer for the question that we get in the top, it says, is the mean is a good representation of the center of data? If not, why? The answer is here. No, the mean is not a good representation of the center. The mean score is 78. And 9 of those scores are better than this. That's the perfect answer.
Wait, is the answer for what question?
Which question?
Question 2, I think. For question 2, right?
Question number 2, yes. Question number 2, what is it saying? If you look at question number 2 here, it said calculate the mean, right? So when you calculate the mean, what you get 78, right? But actually, if you only calculated those numbers, it's going to be more accurate and more centralized. But 15 takes off the data. Is this clear? All right, so let's move on. Now, I have the same data. Remember those data we took before? But this time I'm going to do it with a frequency table. So the number 1, how many times the number 1 is repeated? And how many 3 repeated? 4, 5? Exactly. So the frequency, you write it down here, and then you multiply the number times the frequency. And then after you are done, you add that, you get the total. How much the total? You get how much? The total of those numbers? 29. 29, the total. So we take the 29 and divide by how many numbers? 8. So what's your average or the mean? 3.625. It's the same number we got in the top here. Remember, we got the same number. So either this way or that way, you still get the answer. But remember that we're going to be working more on frequency tables. So you have to get used to this method, the new method. Multiply the number times the frequency. and then you keep repeating this until you get the total. What's the total of those numbers?
The sum, right? Of the
Yeah, the sum of x times f. X is the number, f is the frequency. So try to get used to such table because that's what we're going to use in the future. Okay? Remember we divide by what? By 8.
this column again. The last one.
This one?
Yeah.
It's the result of the multiplication of the number and the frequency.
Babies, what is it called?
It doesn't have a name, it's just x times f. Call it x times f. Until we figure out a name for it.
Any figure name?
God knows.
Oh, okay.
Okay? Can you try to do this now? Different numbers, right? Yalla, 2 minutes. So put the numbers in order and the frequency, and then multiply the number times the frequency, and they get the total. And then divide by the numbers. And what's the purpose of this? To get the mean of the with the frequency. That's called mean with frequency. Finish? Done? What? How much you get? 36? I need the mean with frequency. Yeah, the total is 36. That's correct. But we need the mean with frequency. So the answer will be 4. Why? 36 divided by 9. You got that? You didn't get that? Okay, the answer is here. Lovely table. I spend a lot of time doing this. I can't sleep anymore. Yeah. You like that?
It's beautiful.
Right, thank you. So let's move on. The next step is, what do you think? Median. Median is what? The middle number, right? So I have here the same numbers, right? 1, 3, 3, 4, 4, 4, 5, 5, right? I need to get the median. What's the median? You have to put the numbers in order. So how many numbers I have? 3 here, 3 here, and 2 in the middle. So you have to add those and divide by 2. That give you the middle number or the median. Is this clear?
Yes.
Yalla, your turn now. Prove to me that you understand. So what's the answer? Okay, so you got 10, correct? And the other one is what? 11. Good?
Wait, why is the first one? Can you please explain this?
Which one?
Both of them, because I don't really.
Okay, how many numbers we have? We're looking for the median. Median means what? The middle number. So I have 4 and 9. I put it in order, all the numbers in order, and it's odd, right? So the middle number, which one is the middle in the middle? 10. Okay, and the second one, second number here, how many numbers I have? Is it odd or even? Even. In this case, we have 2 middle numbers, right? 10 and 12. You add them and divide by 2, you get 11. Is this clear? Now we'll go for mode. Mode is the most repeated numbers, okay? So let's go for this one. That's called the third measurement of center, okay? And this is often used in categories or nominal data. All right, let's move on. Example, we have example here. 1, 3, 3, 4, 4, 4, 5. Same numbers, right? What is the mode here? 4. Why? Because 4 is repeated 3 times. Now it's your turn. Can you do this now? Yalla, do it. Finish? So what's the answer for the first one? 4. You sure? Next one, second one? 4 and 16. And the last one? None. Okay, here is the answer. Clear? All right, so we're done with, this is the second type, right? Now, well, the third type. The second type, right? We finish all of them? Okay, I want you to look at this. Can you find the mean and the median for the first number, first set of numbers, and the second set of numbers, and the third set of numbers? And then after you get this, tell me what's the difference between all three sets of numbers. The mean, how much the mean you got? 5. And the median? For all of them, right? Even the spread of the data is different, right? Look. So there is no difference between these three data sets if you just look at the center, but the number are spread out quite differently. The first set of data, the blue one, is spread out very far. The green ones kind of spread out evenly. And the red one has absolutely no spread in it at all yet. Okay? This is why we need something called range. We need some type of measurement to measure the spread of data. So the most basic measure of spread is what we call range. Is this clear? Now let's go for the, I think the first one, right? That's the first one, the range. So the range doesn't go with the center. It goes with something else. It's called variability. Okay? Dispersion, also called variability, scatter, or spread. Common example of measure of statistical dispersion are the range, the variance, the standard deviation, and interquartile range. Is this clear? And I wrote it down here in a table. Okay? So if we take a look at the range, how can I get the range? You know, high minus low. Okay? So for example, I have here 5, 3, 4, 5, 6. Those an example. It's minutes. So if I want to get the range, what should I do?
3 minus 6. 6 minus 6.
6 minus 3. And that gives you the range. The spread of data here is going to be 3 minutes. Is this clear? Another set of data here, I have what? Is it same? Or I think the same, right? So the lowest and the highest. Okay. Another example. 1, 3, 3, 4, 4, 4, 5, 5. Those are the set of data that we had before, right? Remember for the mean, median, and mode, we got this. So to get the range, how much the range will be here? 4. Okay. The problem with range is one extreme value could greatly impact it. So if I added 27 to this set of data up here, what's going to happen? Is it going to affect the result or no? It will affect it. Is it going to be a representative of the data? No, it's not going to be a representative. Why? Because the 27 is off. So here we're going to say 1 minus 27 is going to give you how much? 26. Now you're off too much. So there is a large range between the number when most of them are actually clustered quite closely together. So this is why we need different or better of center. And one measurement for center is what we're going to do, something called interquartile range. And we learned this last time. Okay, so I don't have to repeat this again. So the range is not good. measurement. So we have to find another measurement.
Do we ignore the 57? Is that what we're doing?
You mean to say it's outlier?
Yeah, and just calculate rather than this.
That's if he asks you for that, to which one is the outlier, and you can remove it from the data set. But here is not asking you to remove anything. I'm just explaining what's the difference between each types, because each type has deficits, means something negative about it. Okay. So now we move to, instead of range, now we're gonna go interquartile range, and we did this last time. Okay. Try to find the range for question number 1. Okay. Here. Yalla, go ahead, do it. And then the question comes here, what would you say about the first and the second set of data? What do you get the range for the first one? And the second one? So what would you say about the first and the second set of data? So we can say that extreme data can extreme data can what? Extreme value, for example, extreme one value, right? Extreme one value can greatly affect what? The result. Is that clear? So you can write something like this, similar to it. Okay. Take a look at question number 3.
We add 42 to 57.
Very good. Can you do it?
Comes back to them.
Yeah, write it down. Anything that I don't cover in class, you have to go and read. For example, quartile. How can I calculate quartile? Already we did this last class, so I don't have to repeat it again. You just look in the examples here, beautiful examples. I make it very clear. Just go through the example and the solution. Okay. And there is like do now. You need to do that now. Remember interquartile range? We did this example last time as well, right? So please go through them, read them, and do the test yourself. Okay. Outliers. Now we're going to go for outliers. What is outliers? Do you know what's outliers? What's outliers? What definition of outliers?
Data set lower than the first quartile is going to be an outlier, and the third quartile is higher than we had for I forgot.
So take a look at this picture. Is this representative? Look, the outlier is affecting everybody else, right? So how can I calculate outliers? We have 2 methods. The first method is by graph of the data, and then you can remove that outliers. Okay, this is by calculation. We can do it by standard deviation or interquartile range. By graphing, you just look at the value that is right. Now standard deviation and interquartile rule, we can apply this inshallah. So let's go for example 1. If you got paid 3 weeks in a row but took vacation in the 4th week, so what's going to happen in the 4th week? You're not going to get paid, right?
Yeah.
It's going to be how much? 0. That's bad, right?
Yeah.
So in this case, how would you calculate the mean here? You will add all of them, divide by 3 or 4? 4. So what's your mean? So it's getting affected here, right? Affected by what? The 0. So the 0 is considered as what? Outlier. So it's easy to see it here like this. Another example here, I have big numbers and small numbers. The smallest number is what? 1, and the biggest number 201. So what do you think about the outlier by just looking? It's 1. And what about 201? The number before it's 110. So in this set of random numbers, 1 and 201 are outliers. 1 is an extremely low value and 201 is an extremely high value. Huh? Yes. It could be more. Example number 3. 225, 250, 25, and 235. Which one will consider outlier? 25? Outliers aren't always that obvious. Let us say you receive the following paycheck at last month, 225, 250, 25, and 235. Your average paycheck is what? 135. But the small paycheck 25 might be because you went out for vacation or some reasons. Yeah. So weekly paycheck average is 135 isn't a true reflection of how much you earned. Your average is actually 237. If you take outlier 25 out of the set. Okay. Example number 4. We have 61, 10, 32, 19, 22, 29, 36, 14, 49, and 3. What is the outlier here? 3. Huh?
I think there are more.
What about 61?
Yes.
So, of course, trying to find outlier isn't always that simple. So what should you do? You could take a guess that 3 might be an outlier and perhaps 61. But you would be wrong. 61 is only outlier in this data set. Is the only outlier. It's the only one, not 1, not 3. If we do the calculation, then you will figure out why it's not 3. Exactly. So we have to do this by calculation. Okay? Up to here is clear? So how to calculate outlier? We have a test score here, 32 until 99. Okay? Find the median, first quartile, third quartile, interquartile range, and outlier. So step 1, number 1, what should I do with always you have to do in order first. So put the number from smallest to the largest. Up to here. Step 2, find the median. What's the median? Is a middle number, right? So the median here is going to be, how many numbers total we have? 14. Okay. So 14 means 7 and 7. So that's not going to work. So you have to take the middle 2 numbers. What are the middle 2 numbers? And divide by 2. So your median is what? 78. Or there is another way to do it, is you add all the numbers, like how many numbers you have, 14 plus 1 divided by 2. That gives you 7.5. So when you go 7.5, you will say it's between 77 and 79. The one in the middle is going to be 78. So either way, it's okay. You can do either way. Step number 3, find the first quartile. So we have what? We said we have 14, means we have 7 and 7. So 7 here and 7 there. What will be the middle number here? 67. Because 7, you have 3 on the left, 3 on the right, and the one in the middle is your number. You can do it in another way by, as I told you before, you can say 7 plus 1 divided by 2, and then you look for the fourth position. So you count 1, 2, 3, 4. That's the fourth position.
The one is with the formula, right? Or...
Yeah, with the formula. It's up to you, Yani. You decide either this or that way. Now, what about the third quartile? How can I know? We have 7 numbers, right?
Yeah.
So count 7 and then go for the middle one, or do by the position. 7 plus 1 divide by 2, and the fourth one will be your, so 1, 2, 3, 4. The fourth one will be your third quartile. Now, do you remember the second quartile? What was the second quartile? 78, the one number in the middle here, right? Now we need to find the outlier. Now we need to apply the formula. Step number 5, enter quartile range. Take away quartile 1 from quartile 3, or quartile 3 minus quartile 1. So it's 89 minus 67. That give you what? The interquartile range, which is what? 22.
I'm sorry, I don't understand the purpose of the interquartile range.
You will find out now. Now I got the range which is 22. So now I'm going to apply the formula, which is what? Lower boundary. Quartile 1 minus 1.5 times interquartile range, which is how much the interquartile range we calculated? 22. So 1.5 times 22, 67 minus that. And you get how much? 34. So your lower boundary is 34. Go up here. Do we have a number that is lower than 34? 32. That's outlier. You got that? So we answer your question, correct? Now we answer your question. The second part is upper bound. How can I find the outlier? I need to find the upper part. So we'll do the same thing, but this time instead of subtraction, we're going to do addition. So quartile 3 plus 1.5 times the interquartile range. How much is the interquartile range? 22. So you do the same thing, but this time you're going to add. So how much is the upper boundary? 122. Go to your data up here. Do we have a number above 122? No. So then it's only 32, which is in the lower. Is this clear? That's how you discover or find out what is your outliers, not by looking. Clear? So that's it. Then you write down the outliers is 32. Is this clear?
Yes.
Can you do one now? Yeah, question number 5. Yalla, you try it. How many numbers we have?
7. And then the fourth number was
7. So this quartile 2.
Yes. So I think for quartile 1, we just take these 3 digits, but we also add we take the first 4 digits.
You have to split them equally.
We split
So if you split them equally, you cannot take the 35. Then you take this, right?
So only the first 3 and the last 3.
Right. Because if you take it like, if you take this 4, then 3 will be left. Then you're going to be what, taking this and this? No. So we'll take this. So it's what, here 50 and here is 45. Okay. Which one is the quartile? The quartile 2, 35 is obvious here. So here, what about this one? First quartile is how much? 50. And then the third quartile is 45.
So there are 3.
So you have 3 quartile.
Yeah, but I'm confused about the outlier. Which one? Yeah. 50. Because they seem so close together.
Did you get the interquartile range?
Yeah.
So you subtract quartile 3, quartile 1 from quartile 3, and how much you get? 25. Very good. And then you find the lower boundary. How can I find the lower boundary?
The third quartile plus 1.5 times IQR.
That's the upper boundary. Plus.
Right, yeah.
Okay, and the lower?
It's the same thing, but with the quartile.
And how much the result? 87.5. That's the lower or the upper?
That's the lower.
The 87.5. That's what? No,
I got -3.
no, cannot be that because the numbers here are smaller. How much? 7? I didn't do it, so I don't know the results. Huh? -3? And 77 is the highest? Okay. So there is no outliers. Then you write no outliers. But make sure that your numbers is correct, okay? Next class, we're gonna be starting with variance. Okay? Now variance and standard deviation, and then z-value. So next class we'll continue with this section.